Alrighty, so today we're going to be talking about solving trigonometric ratios. Okay, so before we get started on solving today, we are going to do a tiny review over what we did yesterday. All right, remember yesterday we had the right triangle. Okay, we were given various side lengths. Okay, and we were asked to find the ratios of those side lengths. So thinking back to what we learned about SOHCAHTOA. Okay, so sine is our opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we're thinking about the sine, cosine, and tangent of angle L, first we want to remember the ratios. Okay, so sine is opposite over hypotenuse. So I know I'm working with angle L, so I need to find my opposite, which is 15. That is going to be over my hypotenuse, which is 39. Okay, if I reduce this fraction, I get 5/13, or if I want to find the decimal, we get 0.38. Okay, the cosine of L, remember cosine is adjacent over hypotenuse. So the adjacent side is going to be that side that shares where the vertex is. So 36 is my adjacent. 39 is still my hypotenuse. This reduces to 12/13, or a decimal of 0.92. And last but not least, the tangent. The tangent, again, is opposite over adjacent. Remember, if you think about SOHCAHTOA, that's where we get these ratios from. Okay, so opposite was 15. Adjacent is 36. If we reduce this, we'll have 5/12. Okay, or a ratio of 0.42. Okay, so that's just a quick review of what the trigonometric ratios look like, why we are using those. Okay, so now we're going to focus on solving for missing sides and angles. Okay, so we're still working with SOHCAHTOA. Okay, if we're looking at solving for sides, okay, first we need to figure out which ratio are we actually needing to use. Okay, so we have 3 to choose from: sine, cosine, and tangent. But I need to figure out which one I have to use. So I'm going to start at my angle, and I'm going to say, okay, x is opposite my angle, and then I also have this adjacent side given. So thinking about opposite and adjacent, I know that I have to use tangent. Okay, so the tangent of theta, or my angle, is going to equal opposite over adjacent. Okay, in this case, opposite over adjacent is x over 18. Okay, so the tangent of this angle here is the ratio of these side lengths, opposite over adjacent. So now, in order to solve, we're going to take our angle measurement of 25, okay, plug that in for theta because that's the angle, and then set it equal to our ratio, x over 18. Okay, remember, we are looking for this x value. We need to get this x value by itself. So in order to do that, we have to isolate it by multiplying both sides by 18. Okay, we got to cancel these 18s out. All right, so this is going to leave us with x equals 18 times the tangent of 25. Now, when you go to a calculator, you are going to type this in exactly as it's written. As long as your variable is isolated, this should be lined up the way you need it. So in your calculator, type in 18, press the tan button, and then enter 25 in the parentheses. When you enter this in your calculator, you should get a value of x as being approximately 8.39. Okay, so again, all of this will be done in your calculator. The main part you do on paper or by hand is getting that variable isolated. Okay, so once you type that in your calculator, this will be your answer. Let's look at another example. Okay, so again, we're looking for a missing side length. First step, which ratio do I need? Okay, I have SOHCAHTOA as my guide. Okay, so if I have my angle here, I notice X is my hypotenuse and 15 is my adjacent side. So adjacent and hypotenuse, AH, we need to use cosine. Okay, so the cosine of theta, or our angle measurement, equals the adjacent over hypotenuse. Okay, in this case, we'll have cosine of 70, that is our angle. Okay, adjacent is 15 over our hypotenuse, which is x. Okay, thinking back to our goal of why we're solving, we need to get this missing variable. We need to figure out what our variable is. So in order to do that, we have to isolate it, get it by itself. Okay, I'm going to multiply both sides by x so that I can get rid of my denominator. Okay, so now we have x times the cosine of 70 equals 15, right? Once you're here at this point, we actually have two different terms happening. Anytime you have cosine, sine, or tangent of an angle measurement, this all is one unit, you can say. This all has to stay together. Okay, so again, I need to get my x by itself, so I divide by that cosine 70, because again, that has to stay together, and I do that on both sides. So now we have x equals 15 over the cosine of 70, okay? In your calculator, because my variable is isolated, you will type in 15 divided by cosine of 70, in that order. 15 comes first, divided by symbol cosine 70, okay? When you enter that in, you will get that x is a value of approximately 43.86. Okay, entering this into the calculator is very important because if you type it in incorrectly, it will not give you the right answer. So make sure you have your variable isolated and you type in exactly as it's written. Okay, so that's how we solve for the missing side length of a right triangle, okay, using those trigonometric ratios. Now, let's look at what if we need to figure out the angle measurement. Okay, so up to this point, we've been using just our regular functions, sine, cosine, tangent. Well, there's also something called the inverse, okay? So arc sine or inverse sine is when you have your trigonometric function, okay, but raised to the negative first power, okay? This is just called the inverse. This is what it looks like. You also have cosine, inverse, and then inverse tangent. Okay, so they all have that -1 up above it. And in your calculator, it looks just like this. It's a totally different button. Okay, so what this means, theta is our angle measurement. So whenever you need to find the angle measurement, we're going to say, okay, what is the angle when sine equals this specific number? Okay, so let's look at an example. If we are wanting to find the measure of angle A, okay, so we want to find the measure of angle A. What is that angle? First, I'm going to look and say, okay, what ratio do I have going on? What sides are given to me? Okay, I have an opposite and I have a hypotenuse. Okay, so first step, which ratio? All right, we have opposite over hypotenuse. All right, and thinking about SOHCAHTOA, that is going to be sine. So sine of angle A will equal opposite over hypotenuse. Okay, so we can say sine A equals 18 over 27. Now once we're here, we still want to figure out what A is, okay? So we're going to take this A and we're going to say A, or my angle measurement theta, is going to equal the inverse, so sine to the -1, arc sine of this side ratio, okay? So all we're doing is taking this ratio of our side lengths and then separating it so we can figure out what that angle is, okay? So since we have our angle by itself, you're going to type in your calculator sine inverse. It's an individual button, okay? It should look something just like this on your calculator. Oops, like that. All right, so you'll push that button and then type in your ratio, 18/27, okay? When you type this in, you will find that angle A, is equal to about 41.81, okay? So what that means, with our side lengths 18 and 27, due to that specific ratio, we can find that angle A is 41.81 degrees, okay? Last example, okay? So still, we're looking for the measure of A, right? We want to find out which ratio we're using. So in order to do that, I say I have my opposite side here, and I have an adjacent side here. Thinking of SOHCAHTOA, I know opposite over adjacent is in relation to tangent, okay? So I want to say the tangent of A equals opposite over adjacent, okay? Which, when we write that fraction out, we get 6/20, okay? So this is the ratio of our side lengths, okay? But now we want to find out this angle measurement A. So we're going to take our angle A and set that equal to the inverse tangent, okay, of that side ratio, okay? Plugging this into your calculator. Again, you type it in exactly as it's written, so inverse tangent with that little, make sure it's the correct button. Set your fraction of your ratios, or your ratio fraction in the parentheses, duh, okay? And then once you type that in, you should get that A will be about a measurement of 16.7, okay? So when you have 6 and 20 as your side lengths, this angle A is about 16.7 degrees, okay? Let me know if you have any questions. Work on today's assignment, and good luck.